Department of the Environment's Property Services Agency assumed responsibility for a 113-kilometre stretch of this part of the highway. Running from Butwal in the west to the Narayani River in the east, the overall length was divided into 3 divisions, each with a different terrain. The western division is 38 kilometres long and is mostly through dense forest interspersed with low-lying paddy fields. Only a few tracks were capable of use even by Landrover. Before road building could begin, a base camp had to be established close to the intended starting point. It was not an enviable task for the advance party, who had to live in tents and suffer the discomforts of hot days followed by very cold winter nights. To prepare an area large enough for the base camp, many trees and much dense undergrowth had to be cleared. Slow and exhausting methods of tree felling were employed at first, but a quicker and more efficient system was soon established. The timber was retained for use in construction of the base camp. Although simple methods of planing were adopted, the results were very good. Once a clearing had been established, the main drainage for the camp with a septic tank was installed. The foundations were also laid for stores and workshops in the form of steel hangars sent out from the United Kingdom. Nepalese labour adapted well to concrete mixing and placing. Careful supervision was necessary to ensure uniformity and protection for the fresh concrete. Wheelbarrows were a new device to many of the Nepalese, who preferred the smaller and lighter loads which could be carried in a basket or headpan. To provide some living accommodation during the early stages, prefabricated buildings were sent from the United Kingdom. These were erected along with some buildings of a local brick construction. When the first items of plant arrived, improvised methods and much manpower had to be used to offload them from trucks. Once offloaded, each item was carefully checked for any damage sustained on the long journey around the Cape and across India, and put to use on the camp construction. Emphasis was placed on training local labor for the future. After some initial instruction, the Nepalese adapted well to the use of digger dumpers and power saws, and camp building proceeded rapidly. A setback came when a violent storm caused damage in the camp. Sheltering trees, which had provided comfort and shade, were now regarded as a risk, so tree felling was the order of the day in the interest of safety. An adequate water supply was a great problem. At first it was brought 24 kilometers by tanker. Early attempts to drill for water were unsuccessful, but finally, about 2 kilometers from site, a supply was struck at a depth of 16.5 meters. Suitably filtered and chlorinated, it was pumped to the camp, fulfilling their need even during the dry season. As the camp neared completion, road building got underway. For the internal roads and camp area, a simple form of water-bound macadam was adopted. Crushed stone, watered and rolled, laid on top of a prepared foundation, was adequate for the slow-moving traffic, and with maintenance, lasted the expected life of the camp. To prepare the aggregate for laying, a stone crusher was brought in. Stockpiles were built up so that the material was readily available, allowing the crusher to be moved further along the road. With a need for 1,000 tons of aggregate per week, it was a non-stop operation. Once laid, the grading and leveling of the base course was carried out to fine limits, using motorized graders or a smaller type towed by a tractor. Base camp was completed in June 1969. A few months later, the construction of bridges and culverts began. At first, it was quite a problem to cross rivers, so access was maintained by improvised methods. Where it was necessary to keep traffic moving, a more sophisticated method was essential. This was supplied by a Bailey bridge brought up from Singapore. With 31 major bridges and hundreds of culverts to be built, this was a mammoth task. Bridge foundations were carried down well below the riverbed to avoid damage by scour during the heavy monsoon floods. The abutments and many of the bridge decks were reinforced concrete, an economic construction using aggregates obtainable from the riverbeds. The concreting was carefully controlled with particular attention to curing. Formwork to support the deck during construction was readily available from the forest, and there was no shortage of props. Reinforcement was difficult to get locally, and much of it was shipped from the United Kingdom. The bridge beams on spans of 15 meters were cast in situ and heavily reinforced to carry the traffic loading, and all were made to conform to standard specifications. To prevent erosion taking place on the river banks, steel wire was interwoven into cages called gabions. Filled with boulders and placed in position, they were used to control the course of the river. After a while, natural growth gave further help by binding the loosely packed boulders together so as to form an integral part of the river bank. Although placed mainly on the approaches to the bridge from upstream, some protection downstream is also provided. During the fast-flowing monsoon period, this river control also protects the bridges from scour and erosion. A cheap but effective method of making the bridge parapets was to use precast concrete slabs. Brushing the still wet surface gave a pleasing natural stone appearance. The lightweight slabs were easily handled to fit into position on beams previously cast. As the highway progressed, the heavy stone crushers and other machinery were moved forward. The transportation and setting up of these important items of static plant was a major task. At each site, stockpiles of crushed stone used as the base course for the running surface were gradually built up, ready for laying. In the construction of culverts, built in single and twin spans of 5 to 10 meters, reinforced concrete and brickwork were used. For many of the smaller culverts, precast pipes up to 120 centimeters in diameter were used. These were produced on factory lines at base camp, giving the added advantage of maintaining labor there even during the monsoon period. Once cast, the pipes were transported to the site and laid at frequent intervals across the road to carry the flow from the smaller streams and drainage channels. From June to October each year, the monsoon causes swollen rivers and much flooding of the low-lying areas through which the highway passes. Rivers become raging torrents, severely testing any work which has been carried out in the previous season. Work continued as long as possible under these appalling conditions, whilst access along the highway became more and more difficult. The second division of the British sector is through the Dorney Hills. It was difficult terrain, steep slopes on a tortuous route. Dust was an added nuisance during the dry season, causing discomfort and many breakdowns of plant and machinery. Surveyors selected the best route for traffic to negotiate the hills in comfort and safety. Standards of alignment and gradients had been agreed at the start of the project, when a preliminary route was selected. But a great deal of refinement and local adjustment was necessary as the work progressed. A mammoth task of excavation was involved to keep gradients to acceptable standards. almost 5.5 million cubic meters had to be removed, a high proportion of it rock. This was the most testing and frustrating part of the project, when heavy slips filled work previously done. Explosives were used for much of the harder rock, but most of it was removed by hand, working on steep-sided slopes. This was a grueling task, particularly in the hot season when conditions were like a furnace in the middle of the day, so advantage was taken of the cooler periods in early morning and evening. Much of the excavated material was needed to make embankments. This was put down in layers and hand-tamped before compaction equipment and rollers were brought in. Frequent density tests were made to ensure the right degree of compaction. Many of the workforce were women. Their efforts contributed a great deal to output, quite apart from the added stability and good cheer which their presence brought to the men by having their wives and families with them. Whilst work in the hills was in progress, steps were being taken to move the plant into the eastern division. The move from the hills to this sector was slow and difficult because heavy equipment had to be taken up the steep and winding slopes of a narrow access track. By using this temporary route, an 800-kilometer journey through India was avoided. It also provided an alternative to the use of the ferry at the eastern end. But the steep hill track became unsafe after heavy rain and often had to be closed to traffic, halting progress. The eastern division is 58 kilometers long and is a low-lying area of forest and paddy fields. The methods used in the western sector had been proven through a monsoon period, so they were used in the east, incorporating some modifications learned on the way. The eastern division contained the largest bridges, but they posed little problem due to the experience gained in the early stages of the project. They were all built using galvanized steel superstructures and concrete decks. In November 1972, Minister Geary opened the western division of this British-built sector. The remainder of the road, however, continued in construction for just over 3 years, to December 1975. The design of the highway aimed at providing an all-weather surface at minimum cost, taking into account the amount of traffic that would possibly use the road when the whole of the transcontinental highway is open. All senior supervisory staff were UK-based members of the Property Services Agency. Local supervisors and all the direct labour were Nepalese, and contract labour predominantly Indian. At the peak of activity, a total labour force of some 9,000 was employed. The experience gained and the lessons learned from this unique project are now being put to good use in the construction of the Dharan to Dankuta road in eastern Nepal, an even more formidable project than the East-West Highway.